Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Here we're given or asked for a cube root of a number. So what we need to do is we need to understand first of all what the cube root of 125 is. Well, I know that 5 to the power of 3, 5 cubed is 125, and that's something you need to know off by heart. Therefore, the cube root of 125 is like the opposite, it's the inverse. So the cube root is the inverse of cubing, so that's going to equal 5. So if the cube root of 125 is 5, what's the cube root of minus 125? Well, I know the cube root of 125 is 5 because 5 times 5 times 5 is 125. 5 times itself 3 times is 125. So what times itself 3 times is going to equal minus 125, where it's going to be minus 5 times minus 5, which would be positive 25, times minus 5 will be a negative minus 125. So our answer is going to be minus 5. When we simplify a fraction, we want to try and make the numbers at the top and the bottom as small as we can. So looking at the numbers 24 and 60, we need to think, is there a number we can divide both numbers by? Well, they're both even numbers, so we can divide them both by 2. And that will get us 12 over 30. These are also both even numbers, so we can again divide by 2. And that will give us 6 over 15. Now 6 and 15 are both in the 3 times table, so we can divide them both by 3. And we get the answer of 2 over 5. Now 2 and 5, there's no numbers that go into 2 and 5. And so that is our answer. Now, we could have gone straight from the question to the answer by dividing by 12. And some of you may notice that 24 and 60 are both in the 12 times table, so you could have gone straight there, but it makes absolutely no difference if you divide by 2, then divide by 3, or you could have divided by 2, then divided by 6, or done it in any of those orders. So the key says that a circle represents 8 DVDs, and we're told that on Thursday there are 18 DVDs. So we need to rewrite 18 in kind of lots of 8. So that will be an 8 plus 8, which is 16, plus a 2. So we know it will be 2 full circles. So let's get those 2 full circles in. And that will represent 16. But how do we represent 2? Well, if you think about it, if we cut this up into quarters, each quarter will represent 2. So 2, 4, 6 and 8. So we just need another quarter. And so that would be 8 for the first one, 8 for the second one, and then this little quarter will represent 2, which altogether is 18. Another way of thinking about 19 over 8 is just 19 divided by 8. And to do 19 divided by 8, we put 8 on the outside and we do the bus stop. And we've got 19 there. So 8 doesn't go into 1, so we're just going to move that 1 across. 8 goes into 19 twice, but there are remainders, so we'll need to put some zeros on the end here. And it's remainder 3. 8 goes into 33 times, and there's a remainder of 6. 8 goes into 67 times, and there's a remainder of 4. And 8 actually goes exactly into 40, so we didn't need some of those zeros. So the answer will be 2.375. So for shop A, they're selling the rulers in lots of 3. And so we just need to get our 60 and divide it by 3 to figure out how many lots of 3 we have. So we've got 20. So if one bundle of rulers costs £1.50, then 20 times £1.50 would be £30. So in total it would cost £30 at shop A. We're going to do the same for shop B. Their bundles are 5 rulers, so we're going to do 60 divided by 5, which is 12. So we're going to buy 12 bundles at £2 each, and that will be £24. So the cheapest price is at shop B at £24. So I'm going to just copy that number down again, just make it a bit bigger so we can see what we're doing. Okay, we're asked to work that out, round it to 3 significant figures. That means 3 numbers from the left hand side. So starting here, 1, 2, 3. Now the first number has to be not a 0. So if it was a decimal, we would start counting as soon as it wasn't a 0. After that 4, then we're going to put a line down. Now all the numbers are going to turn into 0 on the right hand side. So these numbers here will all turn to zeros. But before they do, we need to look at this number. Now this number is a decider number. If it is 5 or more, then it will push this number up by 1. If it's less than 5, then nothing will happen. Because it's less than 5, all the numbers to the right will turn into zeros. And with decimals, if they're zeros, we don't need to write them. So the answer would be 30.4. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours. That's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. And I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. If we were to write this decimal in the columns, and some of you might not have used these columns in a while, but we have units here, we have tenths, hundredths, thousandths, that's all we need. So it's going to be 0.182. If you read off the number, it's 182 thousandths. So you just look at where the last digit is and look at what column it is, and reading the digits from left to right, you can put that number, 182, over that last column, 1000. Okay, so it's 182 over 1000, but they're both even numbers, so we can actually cancel it down. It says it wants it in its simplest form, so we can divide top and bottom by 2. And 182, well 180 divided by 2 is 90, so that's going to be 91. Now I'm not sure, I don't think you can cancel that anymore, so I'm going to put that as my answer, 91 over 500. So BidMaths tells us we need to do the indices first, and then we do the adding. So we're going to do the indices. 12 squared means 12 times 12, and that would be 144. 6 squared means 6 times 6, which is 36. So we're going to do 144, the 12 squared, plus the 6 squared, so plus the 36, and that will be 180. So 100% of 120 is 120. And let's put that in a bubble. So we're going to split that bubble up to find out what 10% is. And to find 10%, all we need to do is divide it by 10. So divide 120 by 10, you get 12. And then we want to split that bubble up again into 5%. And 5% is found just by halving it again. And so that would be, or just halving it, so that would be half of 12, which is 6. We could do with 1% as well. And we're trying to get to 26%, so we'll do 1%. So dividing the 10% by 10 again, 1.2. And we could do with 20%, and 20% just means we're going to double the 10%. So double 12 will be 24. So to work out 26%, we need to add these together to get to 26. So we're going to add these numbers here together. Okay, so we've got a 6, a 1.2, and a 24. And we're adding them together. And that would be 11, so carry the 1, and that would be 3. Now, it says to decrease it by 26%. So 26% is 31.2. So we need to subtract that. So we're going to do 120, take away 31.2. So I need to borrow 1 from the 2 to make that a 10, borrow 1 there to make that a 10, and that would be a 9. So 10 take away 2 is 8. 9 take away 1 is 8. And there's a 1 here, so we need to borrow that 1. That's 11 take away 3, which is 8. So our answer is 88.8. Let's rewrite this expression, but with a time sign in. So v times w squared. Now w squared just means times by itself. So we can rewrite that as v times w times w. Okay, so we know v is minus 10. So minus 10. And we know w is minus 4. So it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first. And I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive. 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. A plan is a view that you would get if you were on top of the shape. So you were in an airplane or something looking down on the shape. So the sides of this that we'll see, well, we'd see this bit here, and we would see this bit here. So I'm going to start off with the first bit I shaded, and we've got to figure out what the different lengths will be. Well, this would be 2 centimeters across, and the whole thing is 8 centimeters. The bit we don't want is 3 centimeters, so this part here will be 5. It would look like it was 5 wide. So let's draw that on, and so we've got 2 centimeters down, and we've got 5 across. 1, 2, 3, 4, 5. And this is what it would look like from above. Now the other part will be same 2 centimeters, but it will be 3 centimeters across. So we have 3 centimeters across. Now whenever you have a join or a change in elevation, you need to show that with a line across, and so this will be our completed answer. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So we have a set of vertically opposite angles here and here. And we're going to start with those because we have to find out what m is before we can work out what x is. And vertically opposite angles are always equal, so we've got 13m plus 39 is going to equal 2m plus 149. And we're going to get our lines in there because we're going to solve this. And to solve this, we first of all take away the smaller amount of m, because we've got m's on both sides. We can't really cope with that when we're solving. And so we've got a 13m and a 2m. So we're going to remove the 2m. We're going to take that away from both sides to start off. And so we're left with 11m plus 39. And we've just got the 149 on the right hand side. Next we're going to remove the number. So take away 39 from both sides. And we've got 11m is equal to 110. And then we're going to divide both sides by 11 to find out what m is. So m therefore equals 10. So we know if m equals 10, we can then work out x. And the way we can do that is the fact that this one and this one are both on a straight line. So they are both on this straight line here. So we know that they've got to add up to 180. So let's write that down. 13m plus 39 plus x is equal to 180 degrees, or I don't normally put that in for the working out, I always put that in for the answer. So we can solve this, or well, first of all we know what m is, so it'd be 13 times n, which is 130, and then we can solve this. So let's get my solving lines in. And so that's going to be 169 plus x equals 180. And we're going to just take that away from both sides, the 169. So we've got x equals 11. So the value of x will be 11 degrees. I'm going to start by working out what the building is, or the width of the building is in centimetres. So it says 33 metres. And I'm going to convert that into centimetres by timesing by 100. Okay, now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimetres on our map. So the word integer just means whole number, so we're looking for all the whole numbers that x can be. Well, it says here that x is between -2 and 3. So we can first of all fill out that -1, 0, 1 and 2 are definitely values that x can be. The next thing we look at is, can it be -2? Well, there's no little equal sign underneath the inequality, so it can't be equal to -2. But there is one for the 3, so it can actually equal 3. So to draw this straight line graph, what we're going to do is just pick 3 x coordinates, which is -2, 0 and 2. So I'm going to start off with -2, and I'm just going to substitute it into the equation we've got here. So y equals minus 2 times minus 2, because that's what we're putting in, plus 8. Minus 2 times minus 2 is positive 4. So it's going to be 4 plus 8, which is going to be 12. So at minus 2, our graph is at 12, which will be here. Then we're going to put in x equals 0. So it's going to be y equals minus 2 times 0 plus 8. Anything times 0 is just 0, so it's just going to be 0 plus 8, or just 8. So it's going to be 0, 8 will be our next coordinate. And then finally we've got x equals 2. So it's going to be y equals minus 2 times 2 plus 8. Minus 2 times 2 is going to be minus 4. And minus 4 plus 8, which is the same as 8 take away 4, so that's going to be 4. So at 2 it's going to be 4. So we get our ruler to be able to draw this in. We try our best to make sure it's as neat as we can, and make sure it continues on for the whole graph, so no gaps. Instead of doing 0.43 times 16, what I'm going to do is I'm going to do 43 times 16. So I'm just going to get rid of the decimal and just change it to 43. But I've got to remember what I've done. So how have I managed to do that? Well, I've times it by 100, and that'll be important at the end. And to do 43 times 16, there are loads and loads of different methods. Just pick whichever method you enjoy doing or that you find easiest. I'm going to do the grid method, but it by no means is the best method. It's just the one I'm choosing to do. So 43 is 43, and 16 is 10 and 6. So 40 times 10 is 400. 40 times 6 is 240. 10 times 3 is 30. And 3 times 6 is 18. Then I'm just going to add them all together. So 400 plus 240 plus 30 plus 18. And when you add those all together, you get 688. Okay. Now, the problem is that obviously this is not going to equal 688. What we've done though is we've times it by 100. So to find the answer, all we need to do is divide this, undo that times by 100, so divide it by 100. When we divide that by 100, we get 6.88. To answer this question, we need to cut this shape into two shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20, the length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. A sample space diagram is basically a diagram that shows all the outcomes, and we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3, and we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. So water to orange is 3-2. Ooh. We've got water here and we've got orange squash here. And we're told that we've got 80 centilitres of orange. So we've got 80 here. And we're asked to find the amount of water required. So what we do is we figure out how to get from 2 to 80. Well, we're going to times by 40. If I times that side of the ratio by 40, I've got to times the left-hand side by 40 as well. 3 times 40 is 120. So I'm going to need 120 centilitres of water. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimeters high. And how wide will it be? Well, it will be 2 centimeters wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimeters wide and 1, 2, 3, 4, 5, 6 centimeters tall. There we go. And make sure that you don't add any 3-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly 2-dimensional. The easiest way to compare fractions, decimals and percentages is to convert them all into decimals. So I'm just going to convert this percentage to a decimal, and to do that you just divide by 100. And I'm going to convert this fraction by timesing top and bottom by 10. And we know that 4/10 is 0.4. Then I'm just going to put all of these numbers in a place value grid, place value table. And we've got units, we've got tenths, we've got hundredths. Shouldn't need any more than that. So we've got 0.4, 0.43 and 0.27. Now what we do is we start on the left hand side and we find the smallest, because we're looking for it in ascending order. And the smallest tenth is the 2 there, so it's 0.27. So this is our smallest number, 0.27. Now the next two are equal, so we look at the hundredths, and this technically has a 0 there, so 0 is the next smallest. Now 0.40 was 2/5, so make sure you have the original fraction in and not 0.4. And then the largest one is the 0.43, which was 43%. Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4, and that will be 60. Now we can simplify this further, because I can divide left and right by 2. So that would be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give the right answer. In fact, there's a couple of different methods that you can get the same answer with. For mutually exclusive events for A and B, the probability of A or B is equal to the probability of A plus the probability of B. Now we're given the probability of A or B, which is 0.36, and we're given the probability of A, which is 0.12, And so to work out the probability of B, all we need to do is going to solve this. We're just going to take away 0.12 from both sides, and that will give us 0.24 is equal to the probability of B. So B must be 0.24. It only works if A and B are mutually exclusive though. First thing I'm going to do to answer this question is I'm just going to quickly draw out the shape again, just so I can kind of show the calculations a bit easier. Okay, the first thing I'm going to do on the diagram is convert all of these lengths to centimetres. So we've got 4,200, 1,200, 2,400 and 1,800. And next I'm going to convert them into what the scale says they're going to be in our diagram. So a scale of 1 to 600 means 600 in real life, and this diagram is showing the real life situation, is 1 on our diagram. So I've converted them all into centimetres, and now I need to work out how many centimetres there are going to be on our diagram. So I'm going to start with the 4,200, and all you need to do is divide it by 600, and I get the answer of 7. So it's going to be 7 centimetres on our diagram. 1,200 divided by 600, it's going to be 2. So that's going to be 2 centimetres on our diagram. 2,400 is obviously going to be 4 centimetres. And 1,800, divide that by the 600, it's obviously going to be 3. So it's going to be 3 centimetres. So now we know what it's going to be on our diagram. We draw it. So we're going to do 7 across. So 1, 2, 3, 4, 5, 6, 7 across there. I'm going to do 2 down. So 1, 2, 4 across. 1, 2, 3, 4. I'm going to do the left hand one first, I think. So we're going to do 3 down here. And then we just kind of join it up with what's left over. And that's our diagram. There's a few different methods to find product of prime factors, but I prefer using the bubble method. So we put a circle around 75, and we want to split it up into 2 numbers, so 2 numbers that multiply together to make it. I always pick the smallest that I can think of, which is normally 2, but in this occasion, the easiest one for me would be 5. I think also 3 goes into it, but 5 to me seems nice and easy. It doesn't always have to be the smallest that I pick. So 5 times what is 75? Well, 5 times 15 is 75. And then to make 15, we're going to do 3 times 5. And the reason why I've done some of these bubbles in red is that those are the prime factors, which means they can go to 1 and 5. But if you do 1 and 5, you'll be there all day. So we always stop when we do the prime numbers. And so we're going to write these in a list. So 3, 5, and 5. The product means that we put a times sign between them. But if you notice here, we've got 5 times 5. So a different way of writing that in index form is 5 squared. So our answer will be 3 times 5 squared. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4. And then all we need to do is add the 3/4 and the 2/5. So when you add 2 numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20. So we times that by 4. And so we've got times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it would be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour, because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have 2 powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between 2 powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40. We just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4, because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops. So 23 times 4, which is 92. And we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this, because we can divide top and bottom by 4. So that would be 23 over 7. And then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels, but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And with fractions, you can just times to the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5. 6 into 0, 6 into 0, so that's going to be 500. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones. And how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31. And x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. I'm just going to write the question out so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smars and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a -5 on the outside, so we do -5 times 8x, which is -40x, and -5 times -4, which is actually +20. And a lot of students will write take away 20 there, but that is a -5 on the outside of the brackets there. So it's -5 times the -4 there will give you a +20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. Whenever we solve, we've got to get rid of any fractions or brackets first. Now looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we're going to take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. So we're going to start off with x equals 0, and we're going to write out this equation but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there will be 10. Do the same for 1. So it will be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10, so that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2. So it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus. So it'd be plus 2. Should be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, should be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out so that you've gone beneath the line. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So there are two outcomes that it will rain once in the next 2 days, and that will be rain and not rain, and not rain and rain. So to work out the probability, it will rain on Monday and then not rain on Tuesday. What you're going to do is just multiply 6 over 20 by the 2 over 7. So 6 over 20 times 2 over 7. And that will give us 12 over 140. And to work out the probability, it will not rain on Monday and rain on the Tuesday. We're just going to multiply the 14 over 20 by the 5 over 7. And so that'd be 14 over 20 times 5 over 7. And that will give us, 70 over 140. Now we're looking for the probability it will rain and not rain, or not rain and rain. The word or in probability means add, so we're going to get that 12 over 140 and add it to the 70 over 140, and that will give us 82 over 140, and then we can cancel that down to 41 over 70. In this question we have a right angle triangle and we know 2 of the sides and we're looking for the third one, so that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 millilitres of paint per metre of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every metre of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 millilitres. So we need to first of all work out how many black and red counters there are at the start. Now if you look at the fraction of the probability of picking a black, in your first pick is 2 over 5, and then the second pick is 1 over 4. So you can see that there's 1 less at the numerator and then 1 less overall. So that means we can conclude that there are 2 blacks at the start, 2 black counters, and if there are 2 black counters and there's only black and red counters, then there must be 3 red counters, so that to make up the fact that it's 2 over 5. Okay, so to find the missing probabilities, the first couple are quite simple, because we know that, let's do a different colour, this and this have to add up to 1. And so if the probability of picking a black there is 1/4, then the probability of picking a red must be 3 over 4, because these have to add up to 1. Same with these two, these have to add up to 1. So if we've got 2/5 at the top, the bottom one must be 3/5. And finally, we've got these two here. Now these two here we're not given any fractions for, but given the fact that we started with 2 black and 3 red, we've picked one of the red, so we've got 1 less red, and that means we've got 2 black counters and 2 red counters. So it means that the probability of picking a black is 2 over 4, or 1/2, and the probability of picking a red is 2 over 4, or 1/2. The equation of any straight line can be written as y equals mx plus c. So we need to find the gradient, which is m, and the y-intercept, which is c, for this line. Now, we are given a clue. We're told that it's parallel to this equation here, but we're not really interested in the plus 5 at the end. What we're interested in is what the gradient of this line is, which is 11, because all parallel lines have the same gradient. So we actually know what the gradient is for the line we're trying to work out. It's going to be the same because it's parallel, so it's going to be 11. So all we need to do now is find out what that plus c is. And what we're going to do is we're going to substitute in the values of x and y for the coordinate we're given on the line. So it's going to be 46 equals 11 times 4 plus c. And we just need to solve this. So first thing I'm going to do is just times the 11 and the 4 together to make 44. And then I'm just going to take away the 44 from both sides. So we get 2 equals c, or c equals 2. And we can put that into our equation. And that is our answer. So it's going to be 11x plus 2. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.